All right, let us quickly look at this question on the board. We have rational inequalities. Okay, so rational inequalities is normally written like this, that the right-hand side must always be 0. Okay, so if there is any number here, it has to be moved to the what left-hand side. Now, mistake that somebody will make, or as a student, is to cross multiply here. When you cross multiply by saying this multiply 0, some student will say x minus 2 then become less than or equal to this whole of this one multiply 0 is 0. And at the end of the day, they will tell me that x is less than or equal to, then take this one to this side, x is less than or equal to 2. This is wrong. This is absolutely wrong. Because here we are going to be looking. Sorry, I just lost audio. So my mic just went off. So this method is very wrong. So what we are going to do now is to consider two cases. We are going to look for the critical values. So consider the critical point. Remember that critical point is a boundary where values of x begins. So now let us find the critical points. So we are going to set the numerator and the denominator to 0. So we're going to look at the numerator now. The numerator is x minus 2. We set it to equal to 0. So from there, we get the value for x. And that value we have here is a critical value for x. That is for the numerator. Now let us look at the denominator where we have the undefined point. So what does that mean? It means we are setting x plus 1 equal to 0. So this will now imply that x equal to negative 1. So when you plug this negative 1 into the original inequality, so it will make the inequality undefined. So that is why this denominator is referred to as the undefined points. Now, the next thing we are going to do now, we are going to test intervals, because this x equal to 2 and x equal to negative 1 is known the actual value we are going to have. We are going to test for points. Test for points less than negative 1. So we are going to create an interval. It could be a value less than negative 1. Let's say starting from negative infinity to negative 1. That will be one of the intervals. So we start from negative infinity to negative 1. We are going to test that interval. Then the next one is between x minus 1, that is x greater than negative 1 but less than 2. We are still going to test that interval. Okay, after testing that, the next interval we're going to test is when x is greater than 2 but less than infinity. That means on our right side. So we are going to test for this first interval here. So where we have negative infinity to negative 1, we are going to test for x less than negative 1. So that is where we want to test now. So if at the end of the day, after plugging the particular value into the original inequality, if it gives us exactly 0 or even a negative number, it means that point is what accepted. Now let us choose a value which is immediately less than negative 1 and then plug it into the original inequality. Now what value can we take? You can take any value less than negative 1. It could be negative 2, negative 3, as the case may be. Now let's choose x equal to negative 2. Now let us try that. Then substitute it into the original inequality. Now let's know if it will give us exactly 0 or a value less than 0. So in this kind of inequality, we are looking for a negative value or exactly 0. Now let's go. Plug it into the inequality. We have x minus 2, then all over x plus 1. So now become minus 2 minus 2, then all over minus 2 plus 1. Now the only day the numerator will give us negative 4. So that is minus 2 give us negative 4. Now negative 4 all over minus 2 plus 1 is for negative 1. then the negative can cancel out. So which means we're having positive 4. So this point will be rejected. So in this interval, x cannot lie in this interval. Why? Because it does not give us exactly 0 or even negative number. So x here is greater than 0. So this point is false. So we shall reject this set of values here. Now let's move on to the next interval where we have x greater than negative 1 but less than 2. So we are going to choose a value to represent x in this interval. So immediately after negative 1, we can take 0. We can as well take even 1 and plug it into the original inequality. So if the value gives you a particular value less than 0 or even exactly 0, so it means that point is accepted. Now, what value are we choosing? Let's choose 0. We choose 0. Then plug the 0 into the inequality. Plug it. If it gives you exactly 0 on the right hand side or a negative value, we shall accept the point. So we have 0 minus 2, then all over 0 plus 1. So that leaves us what? With negative 2. So here, since negative 2 is less than 0, so this point is true. So we take that point as one of the solutions. Now let's test the last interval where we have positive 2 and infinity. That means we're going to choose a particular value there that is greater than 2. So test x greater than 2. Then e.g. take x equal to 3. So now plug it into the original inequality. When you do so, if the value gives you exactly 0 or even negative value, it means we shall accept the result from there. So now we have 1 over 4 after testing. So therefore, this point is false. We cannot take the value there. The only accepted point here is this, where x is greater than negative 1 but less than 2. So that is the solution to the answer. But now how do we present our solution? So x minus 2 all over x plus 1 equal to 0. Now, in writing out this inequality, we are going to know which of the value here is included into the inequality and which one is not included. So I'm going to show you that. Now, if you plug x minus 2 into that numerator will give you exactly 0. So since it gives us exactly 0, it means negative 2 is what? Oh, it means x is included there for that numerator. Okay, negative 2. So what we are going to write now, your answer is going to be x is greater than, okay, what is value there? X is greater than what? Negative 1. Then x is less than 2. See that now? So because after plugging x equal to 2 into that numerator, it will give you exactly 0. So that means x is included. 2 is included into our solution. This is how we write it in inequality form. But what if we decide to write it using bracket notation, form of set notation? Now look at this parenthesis here that I just wrote there. So that simply means that particular value is included. Then this other one here that is not as thick and is different from the first one, it means that point there is not included into the inequality. Now if we want to write this solution now in a bracket notation, so this is how I'm going to put it now. It means negative 1, x start from a negative 1 but ends in what? 2. So it means 2 is included. This is what this inequality is talking about. I hope you find this class very interesting. If that is true, help us to share this post so we could get to greater number of students. Bye.